I'm Alan Ross, and this is an APC Media Power Panel. Our power panel is on storage and microgrids. I think it's going to be excellent because we talked a little bit about it. And at the recent IEEE, I brought it up with a number of people who said, boy, everything's changing. So as the managing editor, I've invited two experts in the industry, Vincent Sprenkle. Vince has done a couple of these before. He's as you can see, the director of grid storage Launchpad. We started working with the Pacific Northwest National Lab several years ago and continue to support the work they're doing. You can see the PNNL information right here. Thanks for joining us, Vince.
Well, thank you.
And our next guest is Ahmed Mosa. Ahmed is a utility of the future senior lead for PSE&G. He develops R&D initiatives. So when we were talking about this, we looked for somebody who was where Vincent comes from, the PNNL, which is a national lab. Then Ahmed comes from the field. He's out there doing this day in and day out. They both have a lot of background in this. So with that said, gentlemen, and thank you, Ahmed, for what you do, the organization, you'll see that at the end of this, we will put the website information for PNNL and PSE&G. So let's start with something that I always like to do. What did it look like? What is the history of battery and storage? And I know, Vince, that's really, you've been working in it a long time. So you've lived that history. So I'm going to ask you first, what is the history of storage? And if you want to go into microgrid, you can. But Ahmed, I know you know microgrids. So let's talk about what we have seen in the past.
Yeah, thanks for the question, Alan. Yeah, so I've been working in storage. I guess I added about 16 years now. And so it was interesting coming in early into it. You know, we always looked at that pump storage hydropower, what was out there. So 22, 23 gigawatts of pump storage hydropower. You know, we were under a gigawatt deployed for a number of years. You know, and then we finally, you know, it took us about a decade, you know, from 2008 to about 2019, where we finally hit a gigawatt of installed storage capacity on the grid. You know, and it was a threshold, you know, to be able to do that. But that was a decade to kind of get from those early deployments to where we had what we considered a substantial size. Moving to that 2 gigawatts of deployed storage took a little over a year more to do that.
Oh, wow.
Right now, we're setting somewhere at the end of 25, like 35 gigawatts of installed storage, battery storage on there. So surpassing what we do have in terms of pump storage capacity on there. Now, I will caveat that by most of that pump storage hydropower is a 10-hour duration, where most of those batteries are still in that, you know, under 4 hours on average duration. But, you know, that to move from 16 to 32 gigawatts took about 15 to 18 months in there. So we're really seeing a hockey stick in terms of the deployments going out there for storage in there. So it's been an exciting time to see it take off and is being utilized heavily within the grid space.
So back in the day, what did it take to see that hockey stick start? Because I think the hockey stick is getting even more of a lift. But what was it that what took from 1 to 27 to 36?
So I think a lot of it was, you know, a lot of the early work that was done was proving the value of storage. Okay. We always knew it was a flexible asset, you know, that can improve the reliability and resiliency of the grid. But did it make sense? Could you pencil out the return on investment of that? Could it perform the grid services? And so getting early deployments out there, being able to go in and do the analytics, this is what it can do. This is the payback. Those help set the foundation. And then you've seen changes in market rules come in that actually incentivized and valued, you know, that you could make a stronger return on investment for those cases. So I think that was a large part of it, is demonstrating the value, demonstrating that you could get your money back on this investment. And then I think you've seen technology maturity too.
Okay.
Yeah.
You know, there's an old rule when you do investigative reporting is follow the money. As you say, hey, stop. Ahmed, you can comment on what Vince has said, or pick up on our second topic in there that we're looking for local grids. Yeah.
Yeah, so again, thanks, Alan and APC Media for this invite and to have discussion with Vince is great. So kind of representing here today myself, but let's jump right into it. So I would like to always talk about the energy journey. So from the beginning, it was always about safety. I mean, safety is the most important, like foundation, if you will. Then in the 60s and 70s, there were like, reliability concerns. So utility shifted in reliability. And then you fast forward 2003, we had the East Coast blackout. So now let's focus on transmission, SCADA, communication, the control rules. And then, for today's discussion, fast forward 2012, Superstorm Sandy, in my opinion, that was like the wake-up call. That's when microgrid became a thing. And, in my opinion, the start of the energy storage. As Vince mentioned, we were very familiar with pumped hydro, but now you have a lot of stuff being added in a much larger scale. So I think this is and then of course, after 2012, we have, there's cybersecurity, there's AI, there's a lot of stuff that comes up, but I would maybe stop for the discussion about storage and microgrid. Now, just to, I guess, I'm a huge fan of the labs. And I think, the beauty, like what I try to do is kind of, bridge the gap between the labs and pretty much the field, like you said, what could we utilize from all the experience and all the stuff that's been proven. Energy storage is basically being promised as, I would say like the coffee grid. It's that one entity that will make everything works. I've spent a lot of time in planning. And as Vince mentioned, 4 hours, we're looking for maybe more than 4 hours. So for some entities, 4 hours would do great. For others, you need, maybe like the 8 hours. So, hydro is great because it provides the 10-hour, which pretty much covers almost most of the day. So I think really what's really interesting from the energy storage perspective, it's kind of an emerging technology. So every day you read about, this new advancement, instead of 4 hours, maybe it's 6 hours, you have the peak, the energy. So it's really very exciting times to be in this field. Again, let's maybe focus a little bit about my microgrid. So in a very high level, what is a microgrid? It's the ability for an entity. It could be a very small institution, a building. It could be like a campus to either disconnect from the grid or to operate in parallel with the grid and supply basically part of your load or your full load, or even better, more than what you have, and then pretty much sell the power or share the extra with the grid. So if there's a partnership between utilities and the microgrids, then in my opinion, it's a great marriage really, because we never know. Utilities are doing an excellent job since Sandy and before Sandy and after Sandy to have a more resilient system. But Mother Nature, I guess we cannot really control or very accurately predict the aspect of it. So I think that's why microgrids are here. And I love the title, because if you've been following microgrids for a while, initially it was a lot of natural gas resources like a CHP or a fuel cell, and then some states kind of went the other route. And then what was the logical I would say replacement? It was energy storage. Initially it was solar, but of course solar alone will not be able to accommodate a microgrid. So you kind of had the solar and storage. So I guess in the journey, and this is like, but I've always been told about the 1973 oil embargo and how the whole country kind of learned, in my opinion, what's happening right now in the escalation in the Middle East, without getting political. That's going to put a lot of focus on energy storage, on microgrid, on kind of being more independent. So I'm very optimistic and looking forward to kind of, learning more, as the market. And like I said, follow the money. I would say follow the market. The market is great. Once all these vendors, get together, they're able to make things more productive, more efficient, of course, cheaper, and easier to interconnect.
Okay, no, that's good. What happened in 2012? You mentioned 2012. What was the event?
Yes, that was the Superstorm Sandy. For for the young generation, that was kind of like the wake up call. That was the first time many of us have seen, I guess, the true power of Mother Nature and the impact. So utilities have been kind of rebuilt, and that's when a lot of cities, towns, and others, they started focusing on what a microgrid is. I'm a big fan of the Department of Energy. They really spend a lot of time and effort for the whole resiliency and microgrid.
And in 2012, Sandy hit the Northeast, New York City, and suddenly all of the people on the Northeast said, "Oh, we're not immune to it." Yeah, you see,
Right.
as long as we were getting them in Florida, everything was okay. The minute it started to hit the up in the Northeast, that's when they panicked. But yeah, I remember that storm. Okay, let's talk about where we are now. Just you've kind of already done that. But Ahmed, where do you think we are now as it relates to? We know we're better at both storage, batteries, and microgrids. We know we're better than we were, but specifically today, if I said, how far have we come? What would you say about that?
So I think we came, so this is just generic across the country. So we definitely came a long way. Now, different utilities, they have different reliability standards, resiliency standards. They also have different threats from Mother Nature. You just mentioned Florida, Texas. There's a lot of states, like Puerto Rico, for example, as an island. So there are areas that get, I would say, impacted more than others. So, so you need to kind of pretty much maybe by the ocean and so forth. The United States, unfortunately, we are, I'm not gonna say blessed, but we do have a lot of activities weather related. So we've learned a lot. I said communication, SCADA. We're very resilient as the system. And in parallel, maybe to focus on today's discussion, a lot of customers as well, they kind of saw the need at some locations in the country to add their own resources. So I think initially they had this kind of doomsday scenario, like once in 1,000 years or once in 100 years. So and then you find out again, those are coming more frequent. That's like number one. Number two, and from a cost perspective, having a system that is kind of a standby for an event that may never happen, that is not very financially. So they started looking at different energy markets, and then they saw kind of the benefit of having a system that is pretty much running all the time. And God forbid there's something, they could again disconnect from the grid. So I would say what we have achieved, massive upgrades and enhancement in the whole microgrid controller. In understanding, I've been to a microgrid myself and I've seen the flow. You could kind of see, for example, you're sending the real power from the microgrid to the utility, but you're absorbing reactive power. Once you kind of cut the cord, now you're on your own. So it's kind of a more education for those facilities. I used to be an operator myself. It's an amazing experience. So really learning how to pretty much, I would say, again, you become your own local utility, right? So you're managing your generation versus your load, and then there's a lot of changes. So that's one aspect. Battery storage, which today's discussion, there's been a lot of advancement as well. So this is really, again, the more efficient they become, you're able to pretty much supply most of your power. For some locations, they're all about shelter. So you could kind of put a solar and a kind of battery setup to help maybe like a local high school or local hospital or shelter. But I think we also doing better. I mean, we could do a lot better with the weather forecasting, but the weather is very critical. Right before the storm, during the storm, after the storm, you want to make sure that your energy storage is pretty much fully charged. I think the automation is where we need to do a lot better. In my opinion, I have kind of my own checklist of what's considered like a smarter microgrid. You need to be autonomous in a way because it may be very difficult for you to come to the site during an event to run your microgrid. I think the regulatory bodies are doing a great job. So like I said, Department of Energy, the state commissioners and others, they were promoting microgrids. So we're a lot better than before. For example, before 2012, no one really discussed microgrids. That's kind of why I highlighted this year. It wasn't like a topic people knew anything about. And now here we are, I guess 14 years later, and we continue to develop. And as energy storage become more efficient and I guess more innovative, and I'm also a big fan of mobile energy storage. So you could kind of, if there's an event, you could kind of go to so like I said, the storage will definitely play a very big role as well.
Yeah. Vince, comment on everything that he just said about where we are today, especially as it relates to storage.
No, and I think, it's a great job kind of setting where we are. I always like to go back to where we were. The first microgrid projects that we were involved with were remote areas in Alaska, where DOE was helping out. These were very small scale systems. There was no connection to it. And how do you implement storage to make those hard to transport resources go further, and improve that, to where you started looking at, the next phase of it was really working with a lot of military bases, at that point where they were still connected, but could you develop that microgrid to help them get through a 7-day, a 14-day outage, and what's the right amount of storage with the other resources, and then you're getting into, It's still connected to the grid, and how do you utilize that asset? I think at that point, back to the communications and interfacing with the utility, there were still a lot of issues. To where we are today, I think it's a given that you develop this microgrid. You can do it. There's a lot of interest from large industrial loads to do that microgrid just from a time to power. Can they get there faster and get up to speed faster by having their own microgrid that is still has some connection to the utility, but still understanding what the overall benefits for? What's the benefits to the facility? How can that actually benefit the grid? What's the equitable pay, or fees that would be charged depending on who's able to use those resources. But the scale of it, from the first ones that we did in remote communities to what's being considered now for these, large data centers is just, it's a big a hockey stick, as we saw with just the storage deployments, in terms of the scale at which these microgrids are going towards.
I think Microsoft bought 3 Mile Island, if I'm not mistaken, to try to be their power source for what they're doing. And they're right now, somebody, can't remember who and where, but they're looking to get approval to build an AI data center that is twice the size of Manhattan. It's a huge AI data center. Now they've got local opposition to it, et cetera, but AI data centers are now moving things along faster. Normally we get questions and I read them. I love these ones. They make statements, right? So it's somebody that knows what they're talking about, but they're making a statement. And then they say at the end of it, agreed? So I'm going to ask you first, Vince, and then you, Ahmed, agree to this. A microgrid is a localized small-scale power grid. So that's the first one, defined as small-scale power grid with defined electrical boundaries that generates, stores, and manages electricity for a specific area, like a campus, a neighborhood, or military base. I think you just talked about that. It operates either connected to the main utility grid or independently in island mode to ensure resilience during outages. Stop. Agreed? There's the question.
From my perspective, that covered a lot of it. Ahmed, I'll defer to you on that. You've already been closer with me.
Okay, so
I would say, I would say like 90% agreement. And the only reason I didn't go 100, because to go back to your point where we were, the small scale is getting much larger. So, I would say there's like a nano grid. You could have a few solar panels, a small battery. Now the batteries are getting much larger, putting more panels. There's a lot of cool stuff. One thing we did maybe in the future webinar, the role of EVs. I look at electric vehicle as just battery on wheels. So I think the smaller scale is getting bigger and bigger and bigger. Campuses are massive. So I would say, so 90% agreement just for the small, but otherwise it's great definition, very, very inclusive. And I would say like the name of the game, be an asset. Anything you want to, instead of becoming an obstacle for a grid, be an asset, then you're going to be more than welcome and everything will move much faster.
Yeah, so you're saying the island ones are not as much of an asset or important for the utility, right?
So maybe go back to Vince's point. So like I said, so there are some areas in the country and globally when that's the only source of power. You're in the middle of nowhere. So but what I'm saying is, what I've noticed recently, financially, they want to connect to the grid and sell their generation because your load is not always flat. But it's good because, if there's a gray sky day or like a local event, having an entity you could pretty much control the load, regulate the load, provide generation is definitely a great asset. So I'm a big fan of like being like connected to the grid. If there's something you want to disconnect, that's totally fine. But again, as Vince mentioned, you got to be very careful of. You mentioned an army. The army, by the nature of being, confidential, if you will, in the middle of nowhere, they can't just connect. There's no grid to connect to. So it's a case by case.
Yeah, military applications. If they told us about what they did, then we'd all probably be, be arrested. Yeah, there are some really good questions that are coming in that I've got to make sure we leave time to talk about. So we've come from the past up to about where we are. Both of you couldn't resist talking a little bit about the future. So now it's our time to talk a lot about the future. First, you, Vince, what do you see as the future for storage and for microgrids? And you could treat them as what does it look like together? What do each of them look like but go ahead and talk about what's coming tomorrow.
Okay. Yeah, I think a lot of what I think we still expect the growth. Most of that growth is being developed off lithium ion, technologies. That's what's being deployed. There are a host of other technologies that may not have the supply chain constraints, from a U.S. perspective, that are coming on. So I think you're looking at, entities looking at it much more concentrated on where the technologies are coming from and any vulnerabilities or sensitivities. And that's going to open up, I think, more for some alternating technologies to come into play. I think as we've looked, mainly about storage, but this crosses into the microgrids. We've historically been this move from an hour of storage duration to 2 hours to 4 hours. And as Ahmed said, 8 hours now, but we're starting to see even longer duration, how we can do that. And again, it comes back as you look at large industrial loads, as you're trying to put that in, they're putting those in with, fossil gen sets. Those are ramping up. They don't like to load follow. Can we get even longer duration storage systems that can help offset any kind of ramping capabilities, but also give us an additional buffer. So I think as we go, longer duration enables that much more flexibility in terms of a microgrid configuration and being able to do it with fewer resources.
So when you say different technology, you're saying being able to move away from a dependence on lithium ion?
So I think they're looking at what are alternatives to where, from the U.S. perspective, are there domestic supply chains that support that technology? And so right now, from a technology, we're seeing a lot of interest in sodium ion. So sodium ion utilizes a lot of the same processing and manufacturing resources of lithium ion. Much more abundant raw material in terms of sodium. Now, taking that into battery grade material still needs to be developed, but that's an interest. Flow batteries is one that have been around for quite a while. Vanadium is kind of the current one. They're all kind of, doing that 4 to 8 hours, but we're seeing a shift towards trying to develop, 12 to 24-hour solutions with those. Seeing a focus on trying to develop organic materials to replace that so you don't have that mining or any other type of constraints. So those are just some of the examples of the technologies that we see, that are still trying to get that foothold, in there.
Okay. Ahmed?
Yeah, I just want to add, so
What does the
first,
future look like? You don't have to go back 2012 to 2026, we covered. What does 2030 look like?
no, so I just want to first thank Vince for kind of summarizing. So you're right. I mean, like the flow batteries, you talk about 10 hours plus, we've been kind of promised that hydrogen give you like a seasonal. So the longer the better for utility, of course. But I would also bring to attention something that is very interesting, that, one of the difficulties about microgrids, that they are all different, literally different. Even if you talk about a campus, every microgrid is different. So that's another challenge. It's not like a solar panel. You could just kind of enhance the communication or the interconnection, and that would be great. It's very complex. You're talking about managing generation versus load, a microgrid controller, solar, and then some events do last a long time. Like this winter has been brutal. There's been weeks when the panels have been frozen. So, but I want to bring to attention something different. So I have this kind of small consulting I do. I call it Electric Bridge Consulting. And one of my dreams is to do something I'm calling the Microgrid Avengers. What if we maybe select or volunteer a couple of experts who, across the whole country, and they would kind of, I'm not saying write a standard, but they would kind of give a checklist. Okay, here's what a microgrid in a high level should cover as a minimum. Maybe they become like an IEEE kind of expert or something like that. That way, it's non-biased. It's like no pay. It's just to kind of provide guidance for the campuses, for others, like pretty much like a benchmark for we do some work also with SEPA, Smart Electric Power Lines. They have like a microgrid group. So I think in general, there's a lot of interest. But maybe you could kind of somehow, I was like, that's what I'm calling the Avengers. Like, this team gets together when there's something new, as Vince mentioned. Maybe we don't know how to put like a flow battery inside like a university. So I think that would be, so in my opinion, like I said, the market, and Vince already kind of summarized, the market is doing great. The technology is evolving. I think right now we kind of need to kind of put our kind of engineering, if you want, heads together, plus some kind of market together from an economic perspective, and then have this kind of guidelines, going forward. So it'd be very simple. But again, I just think again that how difficult they are, how different they are, that may impede, the expected progress. But I would say just to conclude on this question, so the energy storage definitely is improving. Solar panels are getting more efficient. Communication is getting more robust, much faster. I think right now with AI, we're able to maybe understand and calculate the expected load and control the load in a much better way. That way you could match generation versus load. And then again, I always say Mother Nature strikes, we build, we make it more resilient, and then wait for the next event and so forth.
A question that just comes from my background, and we publish in a whole community transformer technology. And one of the things that is very clear that it's talked about, the utility industry is addressing it. However, the long lead times on even big power transformers is causing problems of implementing this. Transformers were never made to go both ways. They were made to take it from here to the house or the business. When we look at it now, especially those that are connected to the utility, and we're asking that transformer to it's a step down, and then it becomes a step up. I think it was Southern Cal Edison that did a finding. They did some research on it, and they indicated that transformers that were moving both ways, because of this whole energy storage moving back and forth, were failing twice as fast as transformers that just maintained the old step down. Is that true? Is that just a transformer issue, or is that potentially true of other assets within the SAFE system? What are we finding on that? Let me start with you, Vince. You look like you got an answer.
Well, no, I was I don't know in terms of that. I've heard that about transformers. When we deal with storage, it's nice because it is that flexible asset. But
Right.
I think it is as we're moving forward, understanding the true flexibility of all the grid components is critical in there, because it's going to have to be a two-way flow no matter what we're going for the future here.
Well, I've had some experts in cable, both underground and overhead, and they say the same thing. When cable is expected to go both ways, when it was really pushing one way, it's aging twice as fast. So we're taking an already aging workforce, and with the installation of microgrids and batteries, we're potentially aging it twice as fast. And since we can't and one of them is the geopolitical issues about getting assets into the United States, every major transformer manufacturer, US-based, has added capacity or is adding capacity. I've been at 3 grand openings of transformer capacity. Only 2 of them, or basically 1.5 of them, have supported the 765 grid at the high transmission level. There's not any that are really focused on what I would say the low end of transmission, the high end of distribution. They're still 3 to 4 years out because they're specially made. They're made one at a time for a specific replacement. Sometimes it's the footprint, but whatever, there's a lot changing in the world. Ahmed, the other thing about bringing people together, somebody like you working with us at APC Media, we might be able to support what you're talking about, creating a guideline, not a standard, but a guideline for what we want to do. The Electric Safety and Reliability Association, which is a not-for-profit, would love to put a stamp on that and say, hey, we think this is what a good guideline would be. If you remember, NFPA always said that there's a certain recommendation that you don't open up medium or high voltage panels without PPE. Now they've said, oh, by the way, that's no longer a recommendation. It is now a requirement, but they're not saying that you should now require and open up with PPE. They're saying you should not have anybody open it, period. Well, now you have to figure out what you're doing. So it's giving a whole life to the the windows that people are being able to shoot IR and infrared through. Their business is doubling, tripling as a result of that ruling, because it went from a guideline for 20 years, and it's now a you must. And OSHA is going to regulate according to that you must. So they put teeth in it. We won't put teeth in this, but I think it's a great idea. A non-biased participant, and ESARA and APC Media are that. So I'll be ready for a call on that, because I think it's a brilliant idea.
No, thank you, and that'll be great. And just to kind of, I do agree with you. I think that we have, as a nation, really, I guess, we have to kind of work together. There's a lot of talent, there's a lot of technology, and as you mentioned, there is an infrastructure movement. But you raised up a very good point that the assets, putting aside how old they are, they weren't designed for that. That's for sure. And what's really interesting is, again, I live in New York, for example. You may be in California. We don't share the same weather, so even the reverse flow from one location, it's a uniform reverse flow when the sun rises. If you come to New York City, you get a cloud, humidity. So the transformer is kind of confused. And then you're reversing real power, you're supplying reactive power, and then a cloud comes in. I mean, so I think this is a very important point. And, a lot of us are kind of working with a lot of transformer manufacturer. Just since this is like, my, I guess my wishful list, it would be amazing if we have like a very, very long-term plan as utilities, and maybe the lab could help us, were to standardize the use of transformers. So instead of each one has their own impedance and their own size and their own weight, imagine how simple it is for the manufacturers if a very large portion of us use the same device. And then, for example, to your point, the back feed, forward feed doesn't really matter. It has maybe more than 33, taps for the LTCs. You have the variable impedance. So it's kind of like pretty much going to Vince and, hey, design the super transformer for us. So maybe in the future, that is something we work on. But, the good thing is, like, a lot of us, some of us are ahead. So there's a lot of, a webinar like this and sharing and hearing from others. I think that'll be great.
Okay. All right. Remember, I'm going to call you. What it takes to do things like this is people who are passionate and who are leader oriented. And we could supply a lot of the names of potential companies to do it, but it needs to be kind of like the Transformer Committee. When they get together, they get sometimes 300 up to 600 people that come to the IEEE Transformer Committee. A lot of the vendors that come start with the idea about, hey, let me tell you what we do, right? And I'll tell you what, they get shut down really quickly, because it isn't about you coming here talking about your stuff. It is us talking about standardization. And it took 6 years that way to develop a new DGA gas guide. Well, it was because it was 6 years in the making, and it's supposed to be replaced every 10 years. So they tell me, rather than being 6 years is too long, which I used to say, they now tell me, no, we're 4 years early. Anyway, that's the standards world. I like to do something on guidelines. Let us move to, because I'm looking at the questions that are in here, and they are going to answer the last sequence that we were going to talk about, is what are the barriers? And several of these kind of point to what are the barriers without saying it. Here's the first barrier: the reluctance of utilities and other traditional stakeholders. How can they alleviate their concerns as it relates to battery storage and or smart grids? I assume it's either one. And Arturo Nunez sent this to you. Thank you, Arturo. We're going to throw it to you first, Vince. How reluctant are utilities and other traditional stakeholders? I wish he were on here, because I would say define other traditional stakeholders. But how reluctant are they to accept a new future with storage? And I mean large-scale storage and smart grids. Excuse me, microgrids.
So I can tell you, being in this field for 15 years, there's a lot less resistance to it than there was, a decade ago, just in terms of, we don't want to be first. There's enough out there now. There's enough operating to where those that are just coming into it have enough proof points to go, okay, this is functional, this works. It is we don't need to pilot it, or anything at this point. That's for traditional technologies that have been out there. If you're coming in with a new one, there is still a validation effort that needs to go through to make sure that can work. But I think that resistance is a lot less. The primary barrier that we're seeing right now is safety. What's the
Yeah.
safety feature of the system? That technology come in, and how do we handle that? I would say from a utility perspective, that's the number one question that we get. It's not
Yeah.
necessarily can it perform, but can it perform and safely do it?
That's excellent. That will be something the Electric Safety and Reliability Association will be looking into, because it is electrical safety, but we tie it to reliability. In fact, one of our, I would call him a board member, but he's beyond a board member of ESARA. I'm a board member of ESARA, so I'm talking about that organization. He says, this sounds really good. This is Ron Moore. He is a charter member. He's been there from the beginning. Ron is an expert. He's written, I think, 17 or 18 books. But he says, this sounds really good, safety and reliability. What is the risk or impact on reliability and potential failures or degradation in life of transformers, switchgear, and other electrical equipment in going from AC, DC, from high voltage to low voltage, and vice versa over an extended period of time? It's kind of like what we already said, what's happening to the assets, but it's a little bit broader question. What's it doing to the reliability? And to your point, Vince, what's it do to the safety? Let's start with you on that, Ahmed.
Yeah, no, I mean, so that's a great question, and kind of in line with what Vince mentioned. So right now, globally, I have seen I would say the rise of DC. So some people want to go back, I guess, after all, Edison was correct, right?
Yeah, right.
Instead of Tesla. So you're hearing about, of course, HVDC, we understand one for the lines. But even microgrids, I've seen a lot of news article on that, instead of going from DC to AC, basically eliminating any of the conversion and the efficiency. But as I said before, that's purely my opinion, of course, become an asset. So the prior question about a barrier, sometimes the microgrid may be actually worse for the customer, really. Again, and that's why I mentioned you have this kind of people working together to provide kind of like an honest answer. Not every microgrid proposal is actually more reliable. Sometimes they actually end up reducing the reliability. So I think yeah, I would say everything is on the table now. You become an asset, you're welcome, even if you disconnect and you reduce your demand when the grid needs it. But again, if you want to sell your generation, you have to be an AC to connect to us. But I've seen a lot of small ones, and especially targeting places like in Africa and other areas that doesn't really have the resources, unfortunately. So they've been going the DC route. So that has been very successful there. I think the other question that you mentioned, I guess, about the whole supply chain and the equipment, maybe that's for a different webinar, but the whole asset life cycle is very, very critical nowadays. I mean, if you have a transformer now, you want to keep this transformer forever, because you cannot really afford this. And as you mentioned before, the backfeed, you really want to tamper, and you mentioned DGOA. So a lot of utilities are doing an amazing job to kind of extend the life, because we cannot really afford to wait double the typical 2 years now to 4 years. But just to answer your question, I think all the microgrids are welcome. It just, in my opinion, sometimes there's a disconnect between the customer, the developer, and the utility. So the customer may pretty much get a developer to do the work for them. It's good for the customer to be engaged and kind of understand, what are the pros and cons, for example, if you go DC only versus AC only, and all this conversion. But I mean, I'm sure the lab is doing a lot of work from that perspective, the DC versus AC. But nowadays, and you mentioned 2030 and beyond, I think you're going to see an uptick in the whole DC usage.
Anything to add to that, Vince?
No, I fully agree that, yeah, we're seeing a lot of more interest in the DC. And I think from a battery or storage space, in addition to these large industrial loads just being more powerful, and trying to get it in, we're seeing an increase in the dynamic oscillations of those, especially like in data centers. And so does a DC architecture give us, with a battery incorporated in that, give us that much more speed to respond to those dynamics? Because we're looking at, if you're doing an AI data center that, is doing a training run, you may have oscillations around 10 micros or 10 milliseconds in there. How much can you respond to that? How much the rest of the facility assets all be integrated? And is there a potential delay if you've got to go through that battery system from a DC to AC conversion to be able to do that? And so I think it's a large part of the dynamics. And if you can help reduce that, you can improve the coordination across different assets by utilizing that's a potential benefit there.
Excellent. I love it when you get down into the 10 milliseconds or whatever. You're now down into what people think is not that important, that is that important, right? One thing we have found in talking to the industry, because we have the opportunity to speak to a lot of experts through our magazines, and one of the things that we have heard and had validation from a number of utilities is that this change of the two-way flow of current is creating more transients in the system. So it's creating power quality issues that the operator will find. Well, when you talk about large industrial loads and large loads for AI data centers, they can't have all of these transients, because that's going to, if you've got a robotic system, boop, 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 running down the line, and you got put more transients into the system, and all it takes is one of those robots missing by 10 milliseconds, you're going to have a car that leaks, and a customer that brings the car back in, and they're going to say, well, how could a robot miss that? Well, you have transients in the system. So I know power quality issues are increasing. And to your point, Ahmed, as we're doing these guidelines, we need to say, what are you doing about power quality, and how are you resolving these issues if they happen to come up? But I'll then comment that on this last thing we've been talking about a little bit.
So I'll tell you something that I was working on that I would maybe love to share with you guys offline. I created this kind of a checklist for a smarter microgrid, like going back to for example, remember I said about being an asset?
Yeah.
Coming in and you're already causing a transit problem. And like Vince mentioned, I mean, if you come in with all this kind of problem, and let's imagine this is your proposal, and across the street from you is like a pharmaceutical company or any kind of critical customer. So an ideal one or a smarter microgrid is the one that kind of understands the impact and address it. I always say I would love to connect all the renewables, and if there's an issue, it should be solved on site. Right now we have a lot of inverters play a big role, filters and so forth. So that's really what I would say. And I did see also quickly another question that's mentioned solid state transformer. And as I mentioned, pretty much everything's on the table. They're still kind of relatively small in size, so they're not like a massive substation scale. Maybe you want to, I mean, it would be great if you could find, like, as you mentioned, a critical, like a large customer, industrial customer, when you could kind of test the use of solid state transformer. And if it's proven, it's reliable, resilient, and so forth, then they could pretty much, migrate to the utility system. But I'm going to say one last time, everything is on the table, especially right now with all this issue with supply chain and the lack of resources and so forth.
Okay. By the way, if you send that you said, hey, you're going to send to us offline, go ahead and send it, and we will make it available to all of the people that are on here.
Thank you.
And then you and I'll get together and maybe talk about publishing that in an upcoming issue or edition. Yeah, I got it, because we had a question you saw that question on solid state. Vince, what do you think about this, trying to fix problems by going to solid state transformers? Is it viable? And I met with a large, not named utility that is actually doing some test runs with one of the top 3 manufacturers in the power industry. And, they are well-known: Siemens Energy, Hitachi ABB, Hitachi Energy, and GE Vernova. And they're working with one of them to actually address the issue. How big can we go with a solid state transformer? Any thoughts about that, Vince?
I'm going to admit right off the bat, we're getting out of my wheelhouse when we get into transformers on there. But I do see, everything that we're doing, we're going to need every option on the table, back to Ahmed's comment, to be able to solve this. I think the key, as we've seen with the growth of storage, is ensuring that we can validate and it can scale. So back to your point there. And so, yeah, do we have those capabilities? It's going to take the pilots and other resources to make sure, yes, this is a viable technology. To me, I always look at it as we're looking at something new. does it bring enhanced flexibility to what we can do? Are we more agile on the grid because of this new technology? And so that's when as we start looking at storage solutions or anything else, that's always the big question is, what additional agility does it give us?
Got another good one right now. Energy solution use cases for green microgrids. Any thoughts on that? I'm going to start with you on it, Ahmed.
Yeah, so I mean, so going a couple of years back, initially, I guess when microgrid became a thing, you always, like I said, you had a fuel cell, and you had like a CHP, and it's very reliable, protect from the weather. And then in some states, you kind of decided we don't want to increase the gas footprint. So the only logical was like solar, but solar alone, so it was solar and storage. And then you have EV. So I think that there was definitely a push to make the microgrid cleaner. So again, what resources do you have? You may be lucky and your utility, for example, has like a lot of nuclear generation, so it's already clean, or hydro, as been mentioned a couple of times. But I think locally, the one I would say focus would be like solar plus storage, as we mentioned. If you want to use like a fuel cell or CHP and there's like available like renewable natural gas or hydrogen, I think that's gonna be the future as well. Like we have to we don't drop the bucket or drop the ball on like hydrogen and RNG. We need to understand, what's the impact and the pressure and learn more about CHPs and fuel cells. Recently, there's been a lot of discussion about a lot of fuel cells making their way to the data centers, as you mentioned. Of course, they're going to be a larger scale. Now we're going to go smaller. But I think the other point, which is also very important, is efficiency. The more efficient the microgrid overall become, technically it is greener. But I do agree. Again, the journey that I mentioned before, I kind of stopped at the microgrids, but then you had ESG. We didn't really talk today about cybersecurity, but cybersecurity is very critical. The last thing you need is spend all this money for microgrid, and then the day that you need it, you're very compromised or you can't really operate or something like that. But yeah, definitely, you have to look at I would say the carbon footprint of your microgrid as well.
All right. Vince, any thoughts on that?
No, I think we see a lot as even moving beyond that microgrid back to what Ahmed said, it's looking at the regional resources that you have. So as you look at an area and doing that optimization based on what's available and what makes the most sense, to achieve that, what's the most cost effective, if you're looking at carbon footprint and cost, to make that work. So yeah, we've seen a lot of that where it's more looking at the regional resource optimization.
Next question for us, and we're not going to get all of these questions answered. So for those of you who sent us questions and we don't answer them, we will ask our Vince and Ahmed to comment on them and get that back to you. Microgrids, which are localized energy systems capable of operating independently from the main grid, must comply with strict OSHA regulations to ensure worker safety during installation, operation, and maintenance. Key considerations involve electrical safety, structural safety for equipment, and specialized training for personnel managing distributed energy resources. I think whoever does this then adds agreed or any thoughts. So Ahmed, I'm going to start with you.
So this one is 100%, 100% agreed.
Okay.
And I'll give you a few thoughts. I'll give you a few thoughts. Again, remember when I mentioned that utility is all about safety, a microgrid is nothing but a very, very like small scale utility, if you will. Especially in my opinion, if you're going to operate in an island mode, you're on your own. So now you have to pretty much, especially if you're starting from scratch, you have to run, if you have a diesel generator, a CHP, whatever you have. So you have to manage generation versus load. You're really running a lot of equipment. And there's other aspects of safety. If you have a campus and you don't have enough generation for the entire campus, you may have to kind of, optimize the usage of lighting and stuff like that. So there's a safety from a accident prevention, OSHA, as you mentioned, the operator, they need to be trained the battery is not like a plug and play. There's a lot of, you also have to have like a BMS, battery management system, to look at the health of the battery, stuff like that. So definitely, safety is paramount. And I would say safety, security, and cybersecurity, you're gonna have to somehow mix all three. OSHA and in my opinion, that's one of the reasons that led to many of the developers, instead of being an island mode or basically just like doomsday scenario, because if you operate all the time, if something happened, if there's a fault develops, you would know. The last thing you need is you have this microgrid sitting for 10, 15 years. you have all kind of faults that you don't know about, and then day off you turn it on, and then kind of all hell breaks loose and nothing really works.
all, all hell breaks loose and nothing works. I'm going to end the questions now because I do want to give you all a minute to talk about any additional barriers. I think what you just said, Ahmed, is one of the barriers. We've got to be able to not operate in an island and not get data going constantly. It's much like generators. If you leave a generator and you don't test it frequently, will it run?
Right.
Generators are run on diesel or gas or something. Will it run or will it not start up? There was a recent article published about generators and the startup time and how many of them failed to start up. They were still running the system, but it was close to 50% of the generators either didn't start or had some form of failure. They were supposed to run for X number of hours and they didn't. And part of it is the fuel that they're running on. If you leave a car with gas in it for a long period of time, that gas is going to turn, moisture is going to collect, and you're going to have a hard time. I'm talking from experience now, and you're going to come in home from the airport, get in the car, and the car just sputters. It won't start. But let's talk about any other barriers. Let's start with storage, and your area of expertise, Vince, is what are the barriers to adoption of large-scale battery energy storage systems, I would say?
Yeah, so for years we talked about cost, but as we've moved into more of these microgrids, it's still a consideration, but I think performance is becoming the number one criteria. Can you meet the requirements for it? I still think safety is a barrier overall.
Okay.
I think one that we will see coming up in the microgrid configuration. Well, I'll give you an example first. When we look at a data center, we see storage basically there at a rack level potentially to support those fluctuations at the rack. You've got a UPS system that is ensuring power quality, but can it provide it? And then you probably have a facility-based system. So how do you get all those systems and assets to move in concert? So I see the communications across there. And doing that at a rapid space is a potential barrier that still needs to be addressed. Can we communicate fast enough between resources to be able to manage and mitigate any kind of load fluctuation?
Okay, excellent. Ahmed?
Yeah, I mean, I think as Vince mentioned, as far as the storage itself, the box is getting more efficient, it's getting more innovative, it's getting maybe overall it's cheaper. But we need to focus on what the box is connected to. Maybe the interconnection, kind of running it. What's happening on team, as you mentioned, day to day when you operate it. So I believe there are a lot of challenges, but maybe we'd focus less on the challenge and kind of try to provide solutions. I mean, Vince give you a lot of numbers of how very rapidly the storage has been implemented. So let's, go, again, lesson learned instead of, because we could really raise a lot of issues. It's very easy to raise questions and raise challenges, but let's just see what we have and identify the next critical path. In the beginning, it was cost. Maybe now it's safety. Maybe it's the communication. Maybe how do you communicate during a major event? So I would just say there's a lot of us, again, that's the whole point of kind of the experts working together. You don't have to get it right from the first time, but at least you could start. So I always say it's never the technology. The market will always we'll always recover. I mean, it's just the humans. Like we have to think differently. And like I said again, be an asset. If you're an asset, if the utility and others sees you an asset, I guess they'll bend backwards to work with you. But just in closing, you mentioned 2030. That's very soon. We should learn from all the unfortunate events that is happening nowadays, and to see how again 5-10 years from now when we look back at 2026, what should we have done? Like I said, I'm always reminded about the 1973 oil embargo. But it seemed like the focus was, okay, make stuff more efficient, have some supplies, I guess, locally. But now, again, outside the US, we've been very blessed here. But you read about other countries that now people have to work from home for a long time because they don't have enough gas. I'm talking about a country, not like a city. So
Right.
So now, what is it? Just solar and storage? I mean, what could we do such that if there's a major event like this that happened, we're gonna still be reliable, resilient, and pretty much life goes on.
Right. Last comment, you get the last comment. Tell us a little in that. Make sure you talk about the grid storage Launchpad. You're 1 year old. That is a PNNL effort. Is that correct?
Yeah, so this is actually a new Department of Energy capability that was put on the PNNL campus.
Okay.
So yeah, we opened in August of 24. So we're a year and a half. It's gone fast in there, but it's really focused on how do we accelerate that next generation of technologies. You know, I think we're familiar with the lithium ion story where we had the original patents and research done in the late 70s, early 80s, you know, all the way up through, we got the first one on the grid 2008, and we started seeing it in EVs to where we are today. So the next technology that's going to come in and compete with lithium ion, we can't take 40 years to be able to develop that and get it. And so that's really what the focus of the grid storage Launchpad is in here. So that's whether we're validating new materials will work, up through putting those materials in, you know, industrial relevant pouch and prismatic formats or redox flow battery formats, to being able to test and validate those in the lab up to 100 kilowatt, 400 kilowatt hours. So it's a unique capability in that fundamental science up through real systems with battery management systems and validating those under grid duty cycles, including microgrid applications.
And excellent. Ahmed, you mentioned some of the consulting roles you're on. Talk a little bit about what you're doing right now professionally.
Yes, I mean, just recently, I've been very blessed to we started a new chapter called the IEEE Planet Positive Utility of the Future. So there's an IEEE Planet Positive 2030. It's a great document to read. Talks about all the sustainability. So we kind of added the role of the utility. So we'd love for, I mean, IEEE has almost 500,000 customers, members. So we'd love everybody to participate. It's very, I mean, we cover everything. And as you mentioned, Alan, like I'm just looking forward to kind of working with you. But I'm like an energy addict, so I'm a big believer. You know, I mean, we've been promised when I was young that by the year 2000, we're gonna have flying cars. So we're very late in the game. But I think like globally, there are a lot of people really that are very misfortunate. I mean, you see people living on like one solar panels. So here we're very blessed. But I would say let's just get to work really. I mean, there's a lot of talk and talk and talk. I mean, let's just, if you want to compete with other leading nations, basically you just gotta get to work. So I'm looking forward. Again, this Microgrid Avengers is something I had on my mind. Another thing I call it global energy artist. So what if, those who love this stuff, would participate again at your own hours, of course, you don't conflict with your job and just kind of find a solution. I think Vince mentioned before, we have a lot of pilots. So the days of the pilots are over. I don't have to do a pilot at every state, at every city. If it works well in some, and the systems are comparable, let's move on. And we'd like, I guess, to work with the APC Media. I mean, all the work he has doing for microgrid storage and transformers. But it's been a pleasure. Thank you very much for this opportunity.
It's been excellent. I always say that the utilities have a philosophy. They love to be first, to be second. If somebody's done it, then I can do it. But if you're asking me to be first, I really would prefer to be second. Anyway, thank you both, gentlemen. You're brilliant. I appreciate this so much. This has been an APC Media presentation of a power panel. We will talk, Ahmed and Vince. I'll be in touch about supporting GSL. I'd like to know more about it.
Thank you, Alan.
Pleasure. Thank you.